Today we're looking at factorising, one of those special binomial products we looked at earlier. So when we were looking at expanding, we said that a difference of squares was a special type of expansion that we can work with. So that's when you've got your two brackets and your A value and your B value. So the numbers are the same, but the symbols inside were opposites. So when we were to expand that, what we end up with is A squared minus B squared. So if you can't really remember how that works, make sure you go back to the other video just to check out how we went about expanding it to show that product. What we can now do is we can go backwards. So if I have two square numbers and I'm subtracting them, I can change it back into brackets. Now sometimes we need it in factorized form, particularly later when we look at fractions. We've got algebra and we need to cancel brackets from each other. So when we're looking at these questions, what we want to do is we want to look at each of those terms and be able to write them using a square, so writing them as square numbers. So if we look at this first one, we've got y squared, which is already a square number, and then 64 is actually 8 squared. So what we have there is the a value is y, the b value is 8. And so how we can write it out is we can write in our double brackets. We've got y and 8, y and 8. One of them is going to be a positive and one's going to be a negative. So rather than having to find other methods, and later we'll look at other strategies we can use to factorize these, we've actually got this shortcut. When we look at question B, I've got 9x squared and 4y squared. The first thing I need to do is I need to write it as one unit, for one item, all squared. So if I look at 9x squared, I know 9 is 3 squared, so I could actually write that as 3x all squared. Okay, so we're sort of going backwards in our index laws. So if we wanted to change it back into the original, then if I square the 3 and I square the x, that's how we end up with 9x squared. Then we've got a subtraction, and the other term that we have, 4 is 2 squared, so it's going to be 2y all squared. So what you can see there is that 3x is going to be like our a value, 2y is going to be like our b value. So then we're going to write in our brackets 3x and 2y, 3x and 2y, and then we're going to add and subtract. So it doesn't matter the order, so you can put the subtraction first if you want, and then the addition afterwards. Or you can write it with the plus and then the minus in the order that I've written it in. If we keep going, question C, this time we've actually got the number first, 144, we should know is 12 squared. So 12 squared minus p squared, and then so you can see your two square numbers, and we'll put that in. So when we write this one in, we need to make sure that we write it in the same order that we have it. When we're looking at the plus, when we're adding two terms, it doesn't really matter, but it does when you're subtracting. Okay, so the first term in the subtraction must be the positive square, and then the second one is the one that you're subtracting. Here's a trickier one. So if I've got x plus 1 all squared, you can see that's already got a square on it, so we're going to treat that as one item. And then we've got the 4. So how we could write that out is we've got x plus 1 squared minus 2 squared. Now when we go to do our brackets, they're going to be a little bit bigger because our a term, so the first term there is x plus 1, and then we've got a 2, and then x plus 1, and then the 2. And so what we're going to do is we're going to add the 2, and then we'll subtract the 2 on the other side. What we then need to do with this question is we're going to simplify it. So the first bracket, x plus 1 plus 2 is x plus 3. And your second bracket, x plus 1 minus 2 is x minus 1. So then that's your double brackets. So even though this was in brackets here, if I were to put brackets in there, because I'm adding and subtracting all those items, those brackets don't really matter. The main thing there would be that we need to simplify that. One of the really useful things when we're looking at difference of squares is we can actually use this to calculate values without using a calculator. So we can look at these squares. If I want to work out these differences of squares, I can work these out quite quickly now. So if I look at this first one, we've got 57 squared minus 56 squared. So you can see we've got the squares. So if we apply the rule, we've got 57 plus 56 and 57 minus 56. What we can do is we can calculate the first term. 57 plus 56 is 113, and 57 minus 56 is 1. So then we can work it out without even needing to touch a calculator. When we're looking at question B, again we're going to separate into difference of squares. So it's 128 plus 126 and 128 minus 126. So when we're looking at this first term, that's going to be 254. And we're multiplying that by 128 minus 126 is 2. So that's going to be 508. Let's come to C. So 530 plus 520 and 530 minus 520. So your first term, when we add that together, that's 1050 multiplied by 10. 530 minus 520 is 10. So then we've got 10,500 would be the answer. Hopefully you've got the pattern now. So 125 plus 25, 125 minus 25. So when we add those together, it's 150 multiplied by 100. So then that's going to be 15,000. So that's how we can use some difference of squares. We actually use a fair bit of it when going forward into harder arithmetic. So say for example when we start bringing in some surds, so remember those with those square roots, that's one place where we do use a fair bit of difference of squares.